Hello, it's Keith here, and this is lesson 7 of the Multiplaform series of my Z80 programming tutorials. Now, we've been looking at the past 3 weeks over how to do bitmap graphics on the Spectrum, the Amstrad CPC, the TI-83, and all the other systems we've been looking at so far. Now, up till now, we've just been getting basic graphics to the screen, random pixels and a single letter. But now that we've got that common way of accessing the graphic system of all those systems, we're able to extend that and turn it into a font system so that we can print text to our screen using a common font, and those drivers will basically handle all of the graphics work and let us just worry about the text we want to show on the screen. Also, in addition to that, we can use our platform specific bitmap rendering method and export a common graphic, which you can see is my Chibico character here. We can export that graphic in the format that those systems require for their bitmap screens, and we can do that using my Sprite Editor program here, which is free and open source. And as you can see, I've created an exporter for a wide variety of system hardware. So if you need to get graphics to your screen, this is a good way to get started. And as I say, it's open source, so you can extend it to do more if you need to. So anyway, let's have a look at what we're doing today. Well, hopefully you'll notice one difference for starters. We're no longer using WinApe this week. My tutorials do still support WinApe, of course. WinApe is still my primary development platform. However, because of the direction the tutorials are going to be going, I want to extend them far beyond the capabilities of WinApe. So we're now using Notepad++ and VASM, which is a free assembler, a command line assembler. There's a copy of it available for download on my website. I do plan on integrating it into my development tools download kit, but that's going to take some time because of the testing it requires. I need to test it on all kinds of different versions of Windows and make sure there's no bugs in it. So at this stage, I'm not ready to make that publicly available, but you can download my pre-compiled VASM for Windows, and there's the export scripts that I've made. So I'll just show you very quickly how that works. Hopefully now the font is big enough for everyone, because I can change the font far more freely now that I'm not using WinApe, because WinApe was a little bit limited there. So if I just change this to Goodbye World, which sounds very negative, but let's go with it. So let's see it in action. If we press F6 here, this will load up my command line option here, and we're going to build for the MSX. Now this is just running a batch file, and the batch file will do the compilation. And you can see there's looks like there's no errors there, and then it starts the emulator automatically. And now you can see it says Goodbye World, so that has built just fine. So basically this now allows me to build for any system except for the CPC just as quickly as if I was using WinApe, but it also allows me to build for the CPC. It's just not quite as convenient for me. But I've written these scripts in such a way that they will compile either on WinApe or VASM with no changes. You can see I've used some compiler definitions, and I've made some very slight changes to the layout, so that because VASM is slightly more strict on its requirements. There's a page on my website describing the changes that you have to make to get WinApe code to work on VASM, but it's very trivial. I mean, it's a few minutes work in most cases, and once you get used to it, it's very quick. So anyway, yes, if you don't like WinApe, or you don't use Windows and refuse to use it through an emulator, well, fine. You can now compile, hopefully, all of the new scripts I'm doing, and I'm going back and converting the old ones. You can compile them in VASM, and the reason we're using VASM is VASM supports far more than just the Z80. It supports the GB Z80, which is the Game Boy's processor, which is not a true Z80, and it supports the 6502, then the 68000, which I'm hoping to progress to in later years probably, but I'm hoping to go far beyond the Z80. So this gives us a real endless extent within the VASM assembler to go further. And as I've just said, I am planning on extending beyond the computers we've been looking at the moment. I'm leaving the bitmap lessons for now because I'm not at a stage where I can do the later ones I want to do, but we're going to come back a little later, and we're going to learn how to do similar things on the Game Boy, the Game Boy Color, the Master System, and the Game Gear. For those who don't know, those are virtually the same system. And also we're going to do the contrary to what I said last week, we're going to do the MSX1 graphic system, because I've got some code ready now that will export, that will work in the same way for the MSX1. So we're going to look at that, the MSX1 graphic system, as well as a bitmap device. So anyway, lots of exciting things there to learn in the future. But let's carry on with today's lesson. So what we've got today, I did just show you it running, but I was so quick we didn't really see it. So what we've got is very similar to what we've potentially seen in the past. Last week we had a look at a letter A being printed with the bitmaps, and also a pixel map which was just sort of consecutive byte data. Well, now as soon as OpenMSX gets in time, now you can see we've got a bitmap there, and that's this bitmap here. The colors aren't great, but it doesn't matter. We're going to look at that at a later lesson. So we've got our 4-color bitmap being printed to the screen here in MSX screen mode. Now the MSX screen mode is 16 colors, but I'm only using 4 of them just for convenience. And then the phrase goodbye world here is printed. Now what you possibly can't tell is this is actually a bitmap font that I have exported using my AkuSprite editor. If you go to ZX, and the reason you use ZX is because it's a 2-color system, and you do save 2-bit bitmap Spectrum font, that will export a font file, which I'll show you in a moment, and that will export that to the format that this needs. Why are we doing that? Well, we've now got a very important benefit. If I just move this over here. Okay, well, let's see it running for a different system. Let's build for the SAM Coupe. So what we've got here is we've got the same file being shown on 2 different systems. We've got the same text in the same font because it's the same file. And let's just see that for another system. Let's build for the Amstrad CPC. And you can see here we've got the same image here. Now you'll notice that the bitmap image all looks the same. Now the important thing to notice is the SAM Coupe and the MSX are 16-color systems. I'm just going to close them because they're using all the processing power and turning the fans on, which will make a noise. So even the bitmap, the Chibico bitmap, the colors are different because we've not set the palette. We'll do that later. But the Chibico image looks the same, but it's important to notice that the 4-color and the 16-color systems and the Spectrum and things, they do need the bitmap in different modes, in different formats. And the way we're dealing with that is the Sprite Editor here. It has export options called Export Raw Bitmap, and that is saving the file in the correct image format for those systems. So it's the Sprite Editor that's doing the conversion work there. The bitmap font is common to all the systems because we're using that that black and white bitmap command that we looked at last time. So yeah, we've got these display routines here. The first one's to show the Chibico image, the bitmap. It's quite easy. We just load the memory address of the bitmap. We process the 48 lines that make it up, and then we process the 48 pixels across, but we have to divide by the number of pixels per byte because we're loading the bytes in, not pixels. We send all the bytes to the screen, and we just repeat. The goodbye world text message here, that's even easier because all we do is we use this print string function that we've written, and we're going to have a look at that later. Now the ZX Spectrum does need an extra function. Let's just see that. You can see that Chibico is pink here, and the reason for that is we are using the getColorMempos function, and then we're setting all of the bytes that make up the Chibico square into pink on black to do that. So just a little extra function there for the Spectrum. The Spectrum does need that, the other systems do not. So we'll just exit that as well. And we'll just pause that to hopefully reduce the CPU power. Okay, so there we go. So this is just the test code to actually show the system functioning. You can see down the bottom we're loading there's various versions of the bitmap. They'll all be in the sources file. You can see depending on the color depth of the system, and yes, this even does work on the TI-83. There you go, goodbye world. So you can see we've really got this working on every single system. So there we go. Now of course the work with regards to the font is being done by this new function here called Multiplaform Bitmap Fonts. It tries to mimic the firmware functions we've used in the past, and that's because we're going to replace those firmware functions once we've got things dealt with on the keyboard side. We want to replace everything in one go, so we're going to we're learning the font functions today, and we're going to learn the keyboard functions in later weeks. So we've got our print character command. What this does is it turns on screen drawing on the SAM Coupe because there's memory bank switching we have to do. You should have learned about that last week, the week before, sorry. Then we have two possible fonts. We can have a font with upper and lowercase, which is what you can see here, which uses 96 characters. If you're tight on memory and want to save a few, you can use a 64 character font, which only has uppercase. Generally the other characters are all the same though, so you know you can still have your numbers and your symbols. It's just saving a few characters there. So yeah, if we've only got the uppercase, we have to convert our lowercase symbols to uppercase, and that's all that does. Just compare it, checking if the range is A to Z. If it is, it subtracts 32 to get us into the capitals range. Now the next thing is the first character in the font is a space. There's no symbols below that because they're generally not printable anyway. And again, we need to save as much memory as we can on these 8-bit systems. So we subtract the space to convert the letters into the correct offset for the file. The file is 8 bytes per character because there's 8 lines and each character is 1 byte wide. Remember, it's converted for the screen, so they're all 1 bit per pixel in the file. So we need, if we want character 0, then we would just select the first byte in the file. If we want character 1, we have to move down 8 bytes to get to the first correct line. If we wanted character 2, we have to move 16. So we multiply the character number we want to get to by 8, and we do this by adding HL to itself, doubling it, and then quadrupling it, and that means we end up with 8. We multiply it by 8. We then add it to the start location of the bitmap font file, and then we're ready to start reading in. Now we've got a self-modifying line here. I've had to move because I'm using VASM now, I can no longer put the labels on the right hand side, so I'm now using this new method of just putting a little arrow with the term SM here, which means self-modifying. It's not any suggestion of how abusive the self-modifying code is, it does mean self-modifying. So yep, we've had to make a change there. I don't like it, but we have to, so let's do that. Get screen pos, which is just getting our memory location, because this is going to store the last address we printed a character to, or the next address we want to print a character to, sorry. We then print our 8 lines to the screen, and then we move across the screen by the byte width of the character. Now if we've gone over the screen, then we need to move to the next line, because that was what the firmware would do and we need to mimic it. We then store the new location we want to print the character to, and then we turn the memory banking back off for the SAM coupe, and then we return. We're backing up all of our registers as usual because we don't want to change any registers. We need to try and make sure these functions work the same as our old ones, and the safest thing to do is just back up all our registers. Now you'll also notice I'm only using AFD, BC and HL. I'm not using IX, IY. Important for the Game Boy because the Game Boy doesn't have IX and IY, but that's just another factor at this stage. We're a bit premature there. So we've got a new line command here. We get the current position, we move the cursor to the far left and move down, and then reset the cursor position. Very simple there. So we've got get cursor pos, and this is the same as our get cursor pos command before. All we do is we load in the byte position, we convert it back to a character position, and we're mimicking the same ones as we discussed before, where the top left hand corner is 0, 0, and 1, 1 would be 1 line down and 1 line across. So we've just got to convert back depending on the color depth and things here. So we're doing some shifting of the H register here, and the L register, the L is just the line number, so that's always going to be 8 lines per character. Got a locate command here. So again, nothing particularly complex here. We load the screen height of the system, and we check we're not trying to print off the screen. Now, we don't have any kind of scrolling. The Amstrad CPC and most of the other systems would scroll if you got to the bottom of the screen. I have cheated a little bit. The screen will clear and the cursor will reposition to the top. So it'll do for now, but it's not amazing. But as I say, this is actually enough to get our old examples of reading in input from the user and comparing that input. Remember the sample text adventure kind of thing. We can now run those kind of functions without the firmware font, just with this, so it's enough for now. And again, we just need to do some changes just depending on the screen, how many bytes each character uses on the system. So we're doing some bit shifting here to shift the registers into the correct value, and then we store the new location that the characters want to print to with that self-modifying code up here. Our clear screen command is very, very simple. All we're doing is we're actually using our bitmap, our black and white bitmap command, and we're just setting each of the cursor locations to 0, each byte of the cursor locations to 0. This is very, very inefficient and slow. You probably saw it refreshing. Now, I'm in no way pretending this is adequate for, you know, sort of your gaming uses, but it was just a very quick, easy way of getting the screen to clear in a way that was universal on all the systems, because I already had that bitmap clear, set screen byte black and white command that I knew was safe. So it just a sort of a bit of a kludge for now, but we can write something better. And as I've said before, the functions we're looking at here, they are really the minimal functions that these will get you going. But you know, maybe you want to look at doing something a little bit better if you were writing your own robust game with it. But these are good starting points. They're compatible, and hopefully they're simple enough for you to understand. And finally, we've got print string. Now, this is identical to the previous one. No changes at all. I've just put the BMP header on just because I wanted to recreate it and I didn't want it to conflict with the firmware ones. But we're going to use these to swap out the firmware ones at a later date. So there we go. So that's really all there is to it. There's nothing really too amazingly complex in there. But it's, as I say, it's enough, and it does the job, as you can see. And that's what's going to get us going. So let's just have a very quick look at let's close that. Let's have a quick look at my Sprite Editor. So this is what I used to create the Chibi Akuma's multi-platform version. It's had some extensions since then. You can see we've got a Game Boy option, Sega Master System, Enterprise, Sam Coupe, TI-83, ZX Spectrum, MSX, CPC, and some simple functions here. Now, a lot of these are very specialist. I've basically added functions to it that do exactly what I want. So there's strange options like black border, which will draw a black border around the sprites. Very, very specialist. But that was why I created my own program. As I say, you're welcome to change it. You're welcome to use something else if you want. Now, just to point out, the Game Boy and the Game Boy Color are identical, so you can use that for both. And the Game Gear and the Sega Master System are identical, so you can use that for both. In some cases, the functions are the same for different systems, but as I say, in general, you should be able to find the functions you want just in the menus here, depending on the system you're working on. Now, obviously, the systems beyond the ZX Spectrum here, I'm only really adding for the tutorial, so there's nowhere near the advanced options. But you do have some quite interesting things like there's the save RLE option here for run length encoding, which is something I'm looking at adding in future games that I write. But anyway, say lots of options here. Now you do also have display options. If you were working in screen mode 1 on the Amstrad CPC, you can select it here, and that will limit it to showing 4 colors. If you had more, it would sort of remove them. You can change it to spectrum mode here, and then you can use these options here, and we can if we set this to ZXB for ZX background, now it will only fill in the backgrounds, you see. We can do color swapping here, which allows us to do palette swapping if we wanted to get rid of some of the colors. There's a lot of options here. It's a very crude program. I can't lie. It's a very crude program, but it has a lot of potential, and it can do what you need to. If I want to swap this white with the black, I just turn it on just by clicking on it until the square brackets show, and then I could just click here, and that will remove the color. So there's a lot of options here, and it does support multiple sprites and multiple banks of sprites, which is something that Chibi Akuma has used. It used 4 banks, and it used up to 64 sprites. As well as that, we can, if we load in here and we load the Bitmap font here, you can see this is the font that all of the systems use. Now you can change this font. You could edit it, make it look how you want it to look, and then, as I said before, you can just export it with this Save 2-bit Bitmap font option here. And even though that's in the ZX Spectrum font section, it will work on all the systems. It's just because in the case of my tutorials, I'm using a 2-color font. In Chibi Akuma's, I actually used a 4 and 16 color font, depending on the system. So that's why it's only in the Spectrum section. Now, if you want to edit things in detail, this is a simple pixel editor. You can do things. So you can... got to change that back to foreground. So you can do simple pixel filling here, but if you really want to edit things, what I'd suggest you do is you go to edit here, copy to clipboard, you load up a graphics tool like I use Critter, I don't know how it's pronounced, and then you can make some changes in here, which is obviously a far more advanced tool here. and then if you just copy it into the clipboard again, edit, paste from clipboard, you've got this replace sprite option here, and you can see the changes I've made are represented, and you can load in a bitmap here and paste it in here, and it will use the palette options you've got here. This one here is the transparent color. If you click set palette here, you'll see some square brackets appear, and now I can change one of the palettes. Now turn it off here, and we do have options to export palettes. Save MSX ASM palette, it says copy to clipboard, and it will export in the format required for that system. However, we are going to look at palettes later, and you are not going to need that, because I have a palette function that will handle all of the systems we're looking at in our tutorials that uses the palette format of the Amstrad CPC and the V9990, and it uses that on all of the systems, so you can use the same palette definitions on the MSX as the Sam Coupe, as the Amstrad CPC, as the Amstrad CPC Plus, even the Game Boy Color and the Sega Master System. So the export functions you're seeing here, I just showed you there, those are the ones I used for Chibi Akumas, but they are not the ones you will need for the tutorials, because I've actually elevated things beyond what Chibi Akuma's used for the tutorials. So anyway, I hope you've enjoyed today's lesson. That's actually the end of it. Please have a look at the website and download the source code and the tool I've shown you today, the Sprite Editor. Of course, as always, the documentation is available on the website, so if you prefer to read, please go and have a look at that. I hope you've enjoyed today's lesson. We're going to go far beyond this, as I've always said. I'm nowhere near finished here. We're going to now progress into the keyboard. We're going to start reading the keyboard and the joysticks for all the systems, and then we're going to process those and convert them to key presses so we can read in text input. We're going to go even beyond that, so then we're going to be able to replace the entire firmware. I've got tutorials planned for how to do sound that is not using AkuSprite, or actually going directly to the sound hardware. We're going to be looking at disk operations. I plan to do memory operations as well. As I've said, we're going to even start looking at the games consoles, the Game Gear, the Master System, the Game Boy and the Game Boy Color. So we've got far more stuff we're going to look at. So if you want to keep seeing it, please like and subscribe, and I hope you'll follow me for those episodes. Thanks for watching, and goodbye.